Hey guys, today we're going to talk about another new type of function system, and that is called parametric. And so we're going to ask ourselves, how do I graph an equation in parametric form and then eliminate the parameter? So before we start, let's talk about what a parametric equation is. Basically, what a parametric equation does is it puts the coordinates of a point as a function of a parameter. And so they could use whatever letter that they want, but most of the time they're going to call it t. So what this is going to say here is my x-coordinate will be calculated using this equation, and my y-coordinate will be calculated using this equation, and my t is the value that's changing here, so I can figure out what my x-coordinate is if I know my t, and same for y. So when you go ahead and you graph a parametric equation, you're basically going to do the same thing that you would have graphed before, but now we're going to add an extra column into our little t-charts. So not only am I going to have an x and a y column, I'm also going to have a t column. So, well, that was the least straight line. And so when I look here, the thing about this particular equation is they gave you a set of t's to use. So they said here we're going to use the t's in between -1 and 1. So I'm going to go ahead, and that includes it. I'm going to list those t values in my chart, and now I'm going to go ahead and figure out what my corresponding x's and y's are. So if I plug in -1 into this first equation here for x, I'd have 3 times -1 plus 1, so -3 plus 1 is -2. Then I'd do the same thing for my y-coordinate, and I'd plug in -1 here. So I'd have -1 minus 2 is -3. So that's the first point that I plot. I plot the point -2, -3, and my graph is going by 2's over here because it was kind of small. So I have -2 as my x, and then -1, 2, 3 as my y. Well, except for I totally didn't hit the -3, fail. Okay, and so that would be my first point. And I just continue to do that along the whole chart. So I'd plug in 0, so I'd have 1, and then plug in 0, -2. So my next point would be at 1, -2. And then my final point here, I plug in 1, I'd get 3 times 1 is 3 plus 1 is 4. And then 1 minus 2 is -1. So then I'd have 4, -1. Then I'm going to go ahead and connect the dots. And that's definitely not 4 that I just plotted either. I thought I was making this easier for myself, and I made it harder. Okay, so when I go ahead and I connect the dots to make this equation, I'm going to just use a line because it looks like it's going to be a linear equation. But the big thing about parametric equations is that we have a direction in here. So in a parametric equation, you're going to draw arrows on your graph to say what direction you went. It's kind of like a vector. So if this was my first point, the pink point was my first point, I went to the orange point, and so on and so forth. So I'm going to draw little arrows along my line to say this is the order that I graphed it in. So that's the only thing that's really different about parametric equations. When you see a graph, they're going to have a little arrow on it to tell you which direction, what point you plotted first. Okay, and just like in polar, if we wanted to take this set of equations and make it into rectangular form, we can do that by converting, and instead of calling it converting into rectangular form, they're going to say eliminate the parameter. So basically, the thing that we're going to look for here is we want to know a system of equations, basically. So the goal here is you're going to solve for t in one equation. And it doesn't matter which one you pick whichever one looks easier. So for the case of this one, I probably wouldn't want to solve for t in this first equation. The second one would be a little bit nicer. So if I have y equals t minus 2, all I'd have to do was add 2 to both sides, and I would get t by itself. So I'd have y plus 2 equals t. Now I'm going to take that t and substitute it back into the other equation. So I know that x equals 3 times t, which we just said was y plus 2. And then we add 1. So I could leave this like this. Most of our rectangular equations are going to be solved for y, so I could just solve this out for y. So I'd subtract 7 from both sides, just some basic algebra here. And then finally I divide every piece by 3. So we'd find that this corresponding rectangular equation would be y equals 1/3 x minus 7 over 3, or x over 3 would have been fine, which kind of looks like what this graph was. It looks like it has a slope of 1/3 and has a negative y-intercept, so that makes sense. So that's generally what a parametric equation is. So the next thing we're going to look at are whoa, there goes my papers. A little bit trickier parametric equations, and you'll probably see these a lot. So our goal is to graph the following equations with the direction shown. Again, it's parametric, so we want to tell you where the arrows are, and then eliminate the parameter. So the first thing I'm going to do is actually graph these, and then we're going to try to eliminate the parameter. So again, we're just going to make ourselves a 3-column chart. So we'd have t and x and y, all three of the variables that are represented here. And again, this is like polar. Pick easy numbers to plug in for t here. So I know for the purpose of my cosines and sines, these are the 4 easiest values for me to find, since I can use my OIO chart or the x and y coordinates. So if I go ahead and fill in my x column here, the cosine of 0 is, remember, 1, where the sine of 0 is 0. Then we take the cosine of pi over 2, that's 0, and then the sine of pi over 2 is 1, and then these are going to repeat, but now they're negative, so I'd have -1, 0, and then 0, -1. So again, I'm going to plot these points on my coordinate grid, and I'm going to start at 1, 0, 0, 1, -1, 0, and 0, -1. So I've made a little circle, and again, to show the direction, I'm just going to draw little arrows that said I started and I went around in a counterclockwise motion. So this is just a circle with a radius of 1. So if I went ahead and I was looking at these other graphs, and I wanted to graph, for instance, x equals 4 cosine t or y equals 4 sine t, again, this is one whole set of equations. If you notice and you drew out your t-chart on this one, you would have a circle still, because I would still use all of these same values, but now I'd take that cosine or sine value and multiply it by 4. So then all of my values are going to be the same. The zeros will stay the same, but these will just be 4s. So really what this happened here is this is still a circle, but now my radius is equal to 4. So I could graph this, and I'm not going to use a grid because I'm apparently sucking at that. And again, I go out 4 in all the directions. It's centered at the origin. And then I go ahead, make my circle. And since I know it's going to plot the same way, since cosine was first, I just put my little arrows in to show that it's going that direction. Now, we think about what's going to happen if I have something like number 3. I'll put it over here, where I have the 4 cosine only, the 4 only on the cosine, only on the x-coordinate. So if I went ahead and I drew myself another t-chart, and by t-chart I mean, I don't know, it's like almost like a hashtag now. And again, I pick easy t values here, and then I go ahead and I plug them in. And so 4 times the cosine of 0 is going to be 1 times 4, 4. Cosine of pi over 2 is 0. Again, this will be -4 and then 0. Then I go to my sines, and I have 0. Now this didn't have a 4, so it's just 1, 0, and then -1. So if I plotted this one, what's happening here is I'm going out 4 in the x direction, but I'm only going up 1 in the y direction. So there's 1, -4, and -1. And so this is just an ellipse with a horizontal major axis. So if you look at this guy, this is going to be the same idea, just now instead of having the horizontal major axis, it's on the y that has the 4. So now it's going to have the vertical major axis, or it's going to be one of the long skinny ovals. Okay? So again, we can always make a t-chart to graph these things, but when I'm writing these in rectangular form, I don't really want to have to do a lot of crazy trig and try to solve this for t and do inverse cosines and sines, and that's icky. So there's 2 ways that you could get rid of the parameter, eliminate the parameter, and get this into rectangular form. The first thing I can think of is I have a couple identities involving the squares of cosine and sine. So if I square both of my parametric equations, again, I just squared both sides, and since I did it to both sides, it's a legal move. And then I go ahead and I add x squared plus y squared. I'm going to add both of my equations together. So I added the left sides together, now I'm adding the right sides together. And if you remember this right here, this is a trig identity that we know. Cosine squared plus sine squared is always equal to 1. So I'd have x squared plus y squared equals 1. That's in rectangular form. There's no more t's in my equation. And I would recognize this from the conic section that this is a circle with radius of 1. Well, if I look on this thing, this looks like a circle centered at the origin with radius 1. So if you graph it first and you figure out what shape it makes, it's going to make your life a lot easier. Because then when I'm looking at number 2, I graphed it and I knew that it was just centered at the origin with a radius of 4. So now I have x squared plus y squared equals to 4 squared, or 16. And that was a lot easier than me trying to figure out trig identities and stuff like that. So that's kind of why we went over the circles to begin with. Now on number 3, when you're trying to write the equation of an ellipse, remember you have x squared. This one happened to be centered at the origin as well. I went out 4 on my x-axis, so 4 squared is 16. Then y squared, again centered at the origin. 1 squared is just 1, and that equals to 1. So again, knowing your conics is actually going to help you out on this part of the unit as well. And I have one last thing that we're going to talk about using parametrics, and that's if they try to give you a set of kind of like parameters, a set of instructions to write an equation, a parametric equation with the properties. So it says that we have a slope of 3 and it goes through this point. And so I could look at this equation and I know it's going to go through 1, 2, 3, 4, and then it has that slope of 3, so it's going to go up 3 over 1, or it'll go down 3 over 1. So that's what it's going to look like. So I know if my slope is 3, that means that I go up 3 and then I go to the right 1. Well, when I'm writing a parametric equation, I have an x equals equation and a y equals equation. And so when I think about this slope thing, y corresponds to the up and down motion. So if I take the 3 and multiply it by my parameter t, that would get me that up and down motion. Now if I take the right, that's going to go with my x, so right and left, so I'd have 1 times t, or just t. So that's part of it. Now the only problem here is I need to make sure it goes through this point, and currently I'm not going to go through that point based on these parameters. If I plug in 0 here, I would get that x is 0. So the easiest way I think about it is if I plug in 0, how can I make this true? So if there's a 0 here, what do I need to add? Well, I need a 1. If there's a 0 in for t here, I need to make that y equal to 4, so I add 4. And again, there are lots of different ways you could have made that happen. You could have used a different slope, a larger slope or something, you know, using perhaps 6 over 2 or something. But there are multiple correct answers here, but this is the easiest way I know how to do it. And that's all I've got. I do have a couple example problems if you want to try them, and I will display the answers at the beginning of class tomorrow, so that way you have an idea if you know what you're doing here. Number 1 is going to correspond with the graphing, and then number 2 is very similar to the one that we just did, but you're going to have to find the slope. Okay, I will see you tomorrow.